So here I will solve this question. So we have a uniform rod of length L and mass Mr is set on a pivot and held so that it remains horizontal. So the pivot is located at the distance of L/3 from the left hand of the rod. So this is what our system look like. So if we take this rod and the length of this rod will be L, then the center of this rod will be L/2. And our pivot is set on the left hand at a distance of L/3. Now, two discs of mass MD with negligible thickness have holes in the middle and slide onto the rod on each end. So in this way, they slide one disc from here and one disc from here. Now, they want us to find the expression for the net torque on the rod at instance when it releases in terms of masses of the discs. So they want us to find torque net, which is basically tau net. So tau net is equal to torque due to rod plus torque due to left disc plus torque due to right disc. So we have this horizontal formula, tau is equal to R cross F. Also we can write that tau is equal to RF sine theta. Now what is theta? So when you release this whole system, this will go in this direction, right? And force acting on the rod is in this direction. So the angle between rod and the force acting on it is 90. So we take sine 90 and sine 90 is equal to 1. So the equation will be this. Now we know F is equal to mg, but in this case our F rod will equal to mrg. Mr is given in the question, mass of the rod, and our R will be the distance from the center of the rod, the distance between center of the rod and the pivot. So our R is this. How to find this R? We'll minus L/2 by L/3. So let's minus L/2 by L/3. So by taking LCM, we'll get L/6. So our R is basically L/6. So this is our first equation. Tau rod is equal to F rod dot R rod. F rod is mrg and R rod is L/6. Mr is the mass of the rod. This is gravity. This is length of the distance from the center of the mass and the pivot. Now we'll find the torque due to left disc. So to find the torque due to the left disc, we have this equation like tau left disc is equal to force due to disc dot distance of left disc from pivot. So it's basically this distance. Now if you divide our rod by 3, then this part will be L/3. This part will be L/3 and this part will be L/3. So our rod, our distance is here, somewhat here. So we can take this distance as L/3. So R will be L/3 and F will be mg, which is mdg. So this is the equation for the torque due to the left disc. So why it's negative sign? So torque acting on the left disc is in clockwise direction. So when you release this whole system, the force acting on this side will goes in this direction, which is clockwise direction. So we take this as a negative sign. Now torque due to the right disc. So again in the same way, tau is equal to F dot R, which is force due to the disc and distance from the disc and the pivot. So here our R will be this, which is 2L/3. So if you add L/3 plus 2L/3, if you add L/3 plus L/2, then you will get 2L/3. So our equation for the right side disc will be mdg dot 2L/3. So yes, torque acting on the right side of the disc is in the counterclockwise direction. So we take it negative. Now to find the net torque, torque due to the left disc plus torque due to the rod plus torque due to the right disc. So we'll take all the equations and add it together. Now we'll take g dot L/3 common from each equations. Like we have g by L/3, g dot L/3 here, we have g dot L/3 here, and we have g dot L/3 here. So here we have 2 left in the denominator, and here we have 2 left in the multiplication. So this is as it is. Sorry, g will be taken common. So now we have this term. So let's take this one. So this is minus md plus 2md. So minus 1 plus 2 is equal to 1. In the same way, minus md plus 2md is equal to md. So this and this will give this, and this is as it is. And this is our final equation of torque.